Okay, welcome to the Algebra 2 notes for section 5.5, and I'm going to be looking at function operations. We're going to be doing some adding and multiplying and several other things in this section with function notation. So let's begin with a discussion of function notation. Now you may have seen a little bit of this before in Algebra 1. It looks like this, f of x. And you probably had your Algebra 1 teacher say, just think of it as being the same as y. Well, that's partially true, but it doesn't explain why mathematicians really like this way of doing things, so I'm going to try to give you an idea of why we like it so much. The example I have here is a line with a slope of 2/3 that hits at 8. That's just y equals mx plus b, if you remember that from Algebra 1. And I have an example here using x equals 6. So you can see on both sides here that I'm doing the same work on the right side, taking 2/3 of that x value. Notice I put it inside the pocket. We're going to be doing a lot of that today, putting our replacement values or our input values inside these little parenthesis pockets. 2/3 of 6 is 4. When you add 4 and 8, you get 12. So if you look down here, this says the output value is 12. Now, if you contrast that with the other side, we're going to do the same work on the right. 2/3 of 6 plus 8 is 4 plus 8. That also gives 12. But the difference is we never lost track of that x value. It's part of our final statement down here. So if you read the bottom, you can see that you used a 6 to get the 12, and you know the x and the y. So the first result here is just tells you that, hey, we got 12 for an answer. The other one tells you, yeah, the y value turned out to be 12, but we used a 6 to get it, and because of that, you know both the x and the y. And that's why mathematicians prefer to keep track of all that information instead of losing it halfway through the problem. Okay, so you need to know the anatomy of this sort of notation. So the first thing I'm going to show you here is the first letter, and that letter is simply the name. We use usually letters, the most common ones are F, G, and H. But in upper division math, they even switch alphabets, and you'll see Greek letters like theta or gamma or lambda. But you just put a letter in front, and that gives you kind of a way of saying, hey, you. It gives you a name for the function. The next thing is the little pocket part of it, and that tells you what the input variable or value is. Whatever you put in that little pocket, this is important, has to fill all of those variables. So if it says x in the pocket, then whatever else I put in the pocket, you're going to replace the x's. Then you have the output. Actually, let's look at the actions or rules. On the right-hand side over here is a bunch of stuff you do to the x. In this case, you square it, you multiply by 3, you subtract 5 times that number, and then add 8. So there's all these things you do to the x in order to compute the y, and you'll see those actions on the right. And it usually is on the right. They don't usually turn these around backwards. Okay, the strangest one is the combination. So we talked about the g, that's the name. We talked about the x, that's the input value or variable or even expression. But when you put them together, g of x, you're talking about the output variable. And that's why your Algebra 1 teacher used to have you put a y there, since that's usually used for the output. Okay? It doesn't have to be y value. You can name it anything you want, but that's the typical one that's used. Okay, so I have a little bit of an example here that I'm going to show you. I'm going to plug in the number 4 for the x, and you're going to see me put a 4 in the pocket. I want to find out what value we get when we use 4 as our input. Well, that tells me I need to put 4 over here also. And when you do that, and do all the calculations, you find out that the output would be 36. So what we have here is actually, we just discovered that the point 4 for x and 36 for y, that point is on the graph of this function. Now, that's way up high, so you'd have to have a big old graph to get this thing actually plotted, but you get the idea. And picking the 4 is independent. I could have picked anything I wanted to put in there as long as it turns out to be defined and actually work. Now, there's one other very important note right here that I want to highlight. A lot of times, I'll show you here, a lot of times when you put a symbol up against a parentheses, let me do this a little slower. My internet's having a little issue here. When you do that and you put a number up against a parentheses, what you mean is 3 times this amount. In this context, though, the g of x over here does not mean that. It's not g times x. And if you don't know that, you'll do a lot of damage to your problems, because you'll try to divide by x or you'll try to divide by g, but there's no multiplication between them. That's a symbol, g of x, and it should be taken as a single symbol, g of x. It's got 2 parts to it, the g, which is the name, and the x, which is the input, but when you put it together, g of x is the symbol for the output. We typically call that y. Okay, I'll see you again on the other side for page 2.